Hello, my name is Steve, and today I'm going to be talking to you about my Insight project, modeling ocean conditions for near-empty surf sessions. Or, if that's too much of a mouthful, you can simply think of this project as the Mach Ness Monster. After a nearly 3-week sprint to complete this work, I know I certainly do. This is everything I love about surfing, catching great waves all alone in the middle of nature. It used to be to score conditions like this, you had to have a detailed understanding of meteorological forecasting, understanding the interplay between environmental factors. However, the last 20 years or so has given rise to a number of companies that have made it their business to model when these conditions will occur and provide users with a forecast for the coming surf. As a consequence, lineups are more crowded than they've ever been. This represents not just a safety hazard, but can cut down on a surfer's enjoyment. Sharing the waves with this many people simply means you can't catch as many waves to yourself. So the goal of my project is to get more of this epic surf you see on the left and less of this on the right. My objective was to design a premium crowd forecasting model that could be deployed as a premium subscription feature on one of these forecasting sites. For this proof of concept, I'll be looking specifically at Lindamar Beach in Pacifica, where we'll be fitting our model with a number of temporal and environmental features. Because all the best things happen when you push a giant red button, let me show you what I've come up with. This is Condition Finder, the forward-facing side of Mach Ness. This represents our premium forecasting tool, letting users select their ideal conditions and recommending windows of time over the next week, matching those selections. As implemented, we can select for crowd size, wave quality, and wind quality, with dynamic updates being suggested. And we can send those times matching our ideal conditions to our phone with the touch of a button, so we know when to schedule ourselves as busy over the next week. Now that we've seen it in action, let's talk about what's happening behind the scenes. This is a schematic representation of how Mach Ness works. It all begins with a computer vision screen capture subroutine. Every 15 minutes, a computer logs on to surfline.com, loads the webcam at Lindamar, and captures an image. That image is then fed into a computer vision model that I've trained to identify surfers in the water, and from that, the number of surfers in a given frame is calculated. The average surfers over a given hour will represent the model's target variable. I then include a number of temporal and environmental features to train a random forest model. These features range from day of the week, time of day, to condition data collected from various APIs and websites to model the number of surfers in the water in relation to those feature variables. I've used a random forest model with a 60-40 train test split and tuned the model to avoid overfitting the data, producing a model with an average error of roughly a surfer and a half. Not bad when you consider I'm trying to predict human psychology. Then I feed next week's forecast data into the model to predict the upcoming crowd conditions. And here we see the relative importance of our various predictive features. So this represents a layout of magicseaweed.com, who are the second largest website in this space. And you can see that they have a scale of 1 to 5 ratings for both swell and wind conditions. Now with Condition Finder, we can include the crowd forecast. In this case, 5 out of 5, corresponding to between 0 and 10 surfers in the water. So that's Mach Ness, a proof of concept crowd forecast model with the goal of minimizing crowds and maximizing stoke. Once again, I'm Steve Scherrer, and I'm a recovering marine ecologist. Before coming to Insight, I wrangled sharks and used data-driven approaches to understand where they go. I also developed novel statistical methods to understand long-term changes in Hawaii's second largest fishery as a result of management interventions. This work was so novel, I even had to invent a new type of plot to visualize my results. My curious nature has taken me across the world, and I'm looking forward to my next great adventure working in data science. Thank you again for your time.